Dear student, today I'm going to explain about predictive parsing algorithm with the help of predictive parsing table. Now, this predictive parsing algorithm, as we explained earlier, it's a non-recursive parsing algorithm. It's a top-down parsing approach in which it's consisting of totally five parts. One is the input string to be passed and the parsing algorithm and the stack as an intermediate uh, holder and the parsing table which we have constructed previously. And the output is the production which you are going to use to construct the parsing string or to parse the string. Now the parsing table already we have constructed, which consisting of a two-dimensional array consisting of X is represent the non-terminal sim, A represent the terminal symbol. So which consisting of each row will represent a non-terminal sim, whereas my each column represent a terminal string. Now let us look at each one of them. Input buffer is nothing but our string to be passed. We will assume that it is ends with a marker with a special symbol called dollar, and output is a production rule representing a step of the derivation sequence, that is leftmost derivation of the string in the input buffer. And the stack contains the grammar symbol. At the bottom of the stack, there is a special end marker called symbol dollar. Initially, the stack contains only the symbol dollar and the starting symbol, that is dollar followed by S. That is the initial configuration of the stack. And the stack is emptied. I mean to say that only dollar is left out in the stack. The parsing is completed. If you find a dollar at the end, it means the string has been passed successfully. Now we know that we have constructed a parsing table. It's a two-dimensional array. Each row is a non-terminal symbol. Each column is a terminal symbol or the special symbol dollar. Each entry holds a production rule. Now coming to parsing table, which you have already constructed a parsing table, which uses first and follow. Using this parsing table, first and follow, we constructed a parsing table. So which uses the various steps to construct the parsing table, which I've already explained in the previous video. I'll not be taking about that once again. I'll just discuss about how to pass the given string for the given LL of 1 parsing table. As you know that LL of 1 grammar is nothing but a grammar which is having no left recursion, left factoring. And if at all, if you say that the grammar is LL of 1 grammar, no multiple defined entries is said to be LL of 1 grammar. It means that your parsing table should not have more than one entry in any of the parsing table. If you have more than one entry in the parsing table, then it means that the grammar is not LL of 1 grammar. Now coming to the how the parsing algorithm works. Now it works in this fashion. The symbol at the top of the stack say X, and the current symbol in the input string is say Y, determines the parser action. There are 4 possible parser action. If X is the, I mean to say that X is the non-terminal symbol on the top of the stack, and A is the input string or dollar. It means that the parser halts and say that successful completion. It means that both dollar as well as the top of the stack is also dollar. When we get this is when we reach the end of the string. So then we say that the string has been passed successfully. If X is the top of the stack element and A is the input symbol are the same. If both the input symbol and the top of the stack are both are same, then we say that we pop the X from the stack and move to the next symbol in the input buffer. The third step says that if X is a non-terminal symbol, the parser looks at the parsing table for an entry M of X comma A, where A is the input symbol. So if M of X comma A holds a production, if the production is of type X tends to Y1, Y2 up to YK, what it does is it pops X from the stack and pushes YK, YK1, YK2 up to YN. Please observe that we are pushing the element in the reverse order into the stack. The parser also outputs the production rule, that is X tends to Y1, Y2 up to YK, to represent a step of the derivation. And none of the above. The fourth action says that if none of the above are true, it means that there's an error. All empty entries in the parsing tables are error. If X is a terminal symbol different from A, this is also an error in case of parsing algorithm. It means that if there is no entry in the parsing table, all other entries are considered as the error entries. Let me take one more example, that is how to parse the string using this parsing algorithm. As I explained earlier, we construct the parsing table for the given algorithm, given grammar. The grammar is as follows: S tends to ABA, and the one more is B tends to BB or epsilon. For this particular grammar, I have already explained how to construct a parsing table, which consisting of each row will represent a non-terminal symbol. Each column represent a terminal symbol, and each entries in this table represent the rule we are supposed to apply when S is on the top of the stack if A is the input symbol. With this, I'll be explaining about how the string ABBA is passed using this parsing algorithm. As I said earlier, the rule says that initially we place dollar and S on the top of the stack, and the input is ABBA will be placed into the input buffer, and the action part is specified as an output. Now, if the top of the stack is S, if the input symbol is A, what we are supposed to do is we are supposed to look into the parsing table, that is for the entry S on A is what? S on A is S tends to ABA according to the rule. So we are supposed to give an output as S tends to ABA and then replace S by its production, that is ABA in the reverse order. So S is replaced with ABA. Now the input is ABBA and the top of the stack is A and the input symbol is also A. Since both are terminal symbols, we pop A from the stack and we move further. Now the next input symbol is B and the top of the stack is capital B, and we are supposed to look into the table, that is B on B. That is B on B is nothing but B tends to BB. So we are supposed to replace this B by B and BB and output as B tends to BB. Now my top of the stack is B and the input symbol remains as B. Since both the terminals are matches, we pop the B from the stack and we move further. Now the next input symbol is B and my top of the stack is also B. I'll look into the parsing table, that is B on B is B tends to BB. Once again, we'll replace this B by BB. We are pushing BB in the reverse order so that my top of the stack is B and my input remains as small b. Since both are terminal symbol, they are matching. We are going to pop B from the stack. Now my top of the stack becomes A, B, and now the top of the stack is B and my input is A. So I'll look into the parsing table B on A. B on A is nothing but B tends to epsilon. I'll output the action as B tends to epsilon. It means that B will be popped from the stack. And now my top of the stack is A and my input is also A. Since both are matching, I pop A from the stack. Now my top of the stack is dollar and my input is also dollar. Since both are matching, and if the dollar is also input symbol and dollar is on the top of the stack, we say that string has been passed successfully. Now, whatever the action part you have, you'll use those action part to construct the parsing tree. That is, as if you can look at that, the first output is S tends to ABA. We write that S tends to ABA as the parse tree. Then B is replaced by BB. And once again, B is replaced by BB. And the last B is replaced by epsilon. Now my yield of the tree is ABBA. That is what actually the string has to be passed. That's how the parsing algorithm works. Thank you.